Hello viewers, Electric Circuits question 7. For this circuit, find the total resistance and the current through the battery and each resistor. Therefore find the power output of the battery and the power consumed by each resistor. So in this circuit we have a 48 volt battery, we have a 6 ohm and a 12 ohm resistor in parallel with each other, but in series with that is a 4 ohm resistor. There are two paths here that an individual electron can flow through. The first path would be going through the 4 ohm resistor and the 6 ohm resistor. The second path would be going through the 4 ohm resistor and the 12 ohm resistor. Either way, the electron is going to go through the 4 ohm resistor, regardless of whether it chooses to go through the 6 ohm or the 12 ohm. So that means that the 4 ohm resistor is in series with the two that are in parallel. So we need to work out the total resistance of the circuit to begin with. So total resistance is going to be the resistance of the parallel part plus the resistance of the series part. The resistance of the parallel part is going to be 6 to the power of negative 1 plus 12 to the power of negative 1. And the whole of that to the power of negative 1, so if we calculate that, that's 1 over 6 plus 1 over 12. 1 over 6 is 2 over 12, so we have 2 over 12 plus 1 over 12 is 3 over 12. Take the reciprocal of that, we get 4. And then we need to add the resistor in series, which is 4 ohms, so we get a total resistance of this circuit of 8 ohms. So we've got the total resistance of the circuit so far. The next thing we need to find is the common current, in other words, the current through the battery. So I common is going to be obtained by, as usual, Ohm's law, V upon R. So the voltage of the battery is what we're using here, which is 48, and we're dividing that by the total resistance, which is 8 ohms, giving us 6 amps. So that is the current through the battery. In fact, it's current through this whole part of the circuit. So it's the current through the 4 ohm resistor as well. Now the voltage across these two parallel resistors is not going to be 48 volts because they're only going to see what's left over after the 4 ohm resistor has taken its share of the voltage. So let's work out the voltage across the 4 ohm resistor. So the voltage across the 4 ohm resistor is given by Ohm's law, I times R. Now around this part of the circuit we've found that the current is 6 amps multiplied by the resistance is 4, so we get 24 volts across the 4 ohm resistor, which means that there is 48 volts minus the 24 volts used up by this thing left over for these two. So therefore the voltage across the 6 ohm resistor must also be 24 volts, which is 48 minus 24, and the voltage across the 12 ohm resistor is the same, is also 24 volts for the same reason. Okay, so we've got the voltage across each resistor. Now we need to find the current across the 6 ohm and the 12 ohm resistors. So the current across the 6 ohm resistor is V over R. We've just found the voltage across the 6 ohm resistor to be 24 volts, and we're dividing by the resistance, which is 6, which gives us 4 amps. Now similarly, we can find the current across the 12 ohm resistor, which is V over R, which is 24 divided by 12, giving us 2 amps. So we've got 6 amps around that part of the circuit. We get 4 amps flowing through the 6 ohm resistor here. and 2 amps flowing around through the 12 ohm resistor. So we've got the current through each resistor. Now we need to find the power. First of all, the power output of the battery. So the power of the battery is going to be given by power is current times voltage, which is, for the battery, the current going through it is 6, and we're multiplying by 48. And if we work out 6 times 48, we get 288 watts, which is what's the output of the battery, and the power consumed by each of the resistors must add up to 288. So the power, let's look at the power consumed by the 4 ohm resistor. Power of the 4 ohm resistor is I times V, which is the current across this resistor is 6 times the voltage there is 24, giving us 144 watts. And then we need to find the power consumed by each of the 2 resistors in parallel. So the power of the 6 ohm resistor is I times V. We've already found that the current across the 6 ohm resistor is 4 amps multiplied by the voltage across each resistor is 24 volts, and if we calculate that, 4 times 24 is 96. And we need to find the power across the 12 ohm resistor, which is again I times V. The current across the 12 ohm resistor we've found to be 2, and the voltage across it is 24 volts, and if we calculate that, we get 48 watts. So just to check, 144 plus 96 plus 48 is 288, which is exactly what we're expecting there. Thanks for watching. Over and out.